Hi, uh, this is an attendance access control system using a fingerprint sensor, Raspberry Pi, cloud, and electronic door lock. Instead of electronic door lock, we are using two LEDs to determine whether the access is granted or access is denied. It is actually for multinational companies with remote management. So we can manage this with any location using cloud technologies like an Apache server, which is installed in a Ubuntu, and this thing has a actuator, sensor, and edge computing, and a rule engine which is integrated all into the system. So as part of smart systems module, we have an hands-on experiments on this Raspberry Pi coding and sensors and actuators and communication technologies, everything. So we are using OpenStack as Ubuntu server, and inside that we have installed Apache, Flask, and already routed everything. So here you can see when the user uses the fingerprint sensor, the data is sent to the Raspberry Pi controller. The Raspberry Pi controller does its thing and sent to the cloud-based rule engine, and cloud-based rule engine will check with the user database and grant whether the user can access the system or not. That kind of information will be sent back to the Raspberry Pi controller, and Raspberry Pi controller will actuate the electronic door lock or the LEDs here. So our aim uh, is to design a fully functional system to authenticate and mark attendance using a centralized management system. So here the company can be in any other country and the system can be in UK, and we can actually control all these employees in and out, everything using this cloud technology and these Raspberry Pi controllers. So we will be going through the literature and finding out how we can do this, and we found a solution for this one to log and analyze and adding fingerprints, and we are using an UART fingerprint sensor. This is the fingerprint sensor you can see here. This is a capacitive sensor. Instead of optical reflections, we are using a capacitive mode to analyze the fingerprints. The fingerprints is actually converted into a matrix of numbers, and that matrix is actually used to calculate eigenvalue, and this eigenvalue is used to calculate the and compare the fingerprints that when a person needs to authenticate. So this data is stored in a database, and we are using MongoDB for the database. You can see here the MongoDB is being used, and we actually programmed a UI for this one in React.js, and this thing works all together to actually mark the attendance, record the device, and grant the access and everything. So this is a fingerprint sensor. Fingerprint sensor has a voltage in diagram here. This voltage in is connected to 3.3 volt, and it has a ground pin, RX, TX, RST. We will be explaining it in the next slide. When we go to the Raspberry Pi, you can see that this is the Raspberry Pi controller diagram, and there are the pin circuits here, and in first pin we are actually connected the power of this fingerprint sensor. So this is connected to the 3.3 volt here, and to the 8th pin we have connected TX, that is TX means transmission of UART, that is a serial port here, to the fingerprints RX, that is means this transmit the message from Raspberry Pi to the receiver end of this fingerprint sensor, and this green wire is RX, that is receiving end of this Raspberry Pi, which is connected to the transmitting end of this fingerprint sensor. So GPIO 23 and 24 is used as RST and wake pins. So RST is to turn on the fingerprint sensor, and when the RST is set to low, it will actually make the fingerprint sensor standby. If the fingerprint sensor is in standby, when we place a finger, it turns on the wake pin, that is an input pin here. When wake pin is activated, it will ask the Raspberry Pi Python program to activate the RST pin and record the fingerprint, or either compare the fingerprint. So other devices connected to this include one red LED that is actually communicating with us as access denied, and green LED where the access is granted, and yellow LED is the standby LED to identify whether the fingerprint is in standby mode, or is there anything going on inside that. Edge server. So the algorithm of edge server starts with the comparison level. We will set the comparison level to 5. Then we open the thread to listen to the server and fingerprint sensor. So what happens is, like, it will check whether any communication is there with the server, and if there is any communication like to add the device or map the device, it will run a function according to that. And if the server return add fingerprint means, it will ask the user to place the fingerprint on the sensor, and this yellow LED flash will flash the yellow LED, and the fingerprint will be added with the along with the serial number of this device to the database. And if the finger is on the sensor, wake pin will be activated, and if the matching fails, it will flash a red LED. That means the door will be locked, and it communicates with the user that your access is not granted. If the matching is successful, it will send to the server whether the access is granted with the database as well. If the database have the access granted flag inside that, then it will unlock the door. So in the rule engine, we have a user login system just to run all the primary functions, and we have a dashboard data that we have already programmed to get how many employees are there, how many members are using the system, and how many devices are there. And this can be used to add new devices, like this fingerprint sensor will be added on the next step. So, and there is a staff list, and there is a when the staff list is when you ask to add a fingerprint, then a request type is sent, and the edge server will add the fingerprint. So the connection here you can see is this is the voltage pin, like 3.3 volts. This is the ground for the fingerprint sensor. This is the transmission line, and this is a receiving line from the serial port, and this is a receiving end and transmission end on the fingerprint sensor. And this is the wake pin, and this is the RST pin. This is the ground for the LEDs, and this is for the red LED, this is for the green LED, and this is for the yellow LED. So it is on 32 and 36 accordingly, and 22 for red LED. And here on the 18, that is BGM layout 18 and GPIO 24, you can see the wake pin is integrated, and RST pin is integrated, and on 23 the wake pin is integrated. So we will go to the application, we will log in here. So these are the number of employees here. Here we have a employees panel where we can see how many employees have already created inside the system. We can add new employee using a form here. This will insert the data into the database. So so you can see the user we just added has been added to the database as well. So after that we will be going to the devices, and we have to map this device to the sensor. So we will add new device and send a fingerprint sensor request to the UART sensor here, or like this Raspberry Pi, and we are waiting for pairing the device. And you can see here in fingerprint successfully mapped the device. That means the device has already mapped, and this fingerprint sensor is active. The serial number we have given to this fingerprint sensor is 100, so it is already active here. So as we have added the fingerprint sensor to the database in the MongoDB, so here in the devices we can see the fingerprint sensor is online here. So we will go back to the system, and now we will add a fingerprint here. So we'll choose the system, and I have placed my finger here and asked to add a fingerprint here. It will wait for the fingerprint. Now it is mapping. Let's check the device log. Failed the timeout. Fingerprint added successfully. So here, when the fingerprint is added successfully, it will show that the fingerprints list has one user ID, and if we need to add another finger, we can add that by sending another request as well. We will be add another finger. So fingerprint is active. So we have two fingers added to the system. So once the fingerprint is added, what we can see that yellow LED is blinking. So in order to like authenticate and mark the attendance, we will be placing our finger here. So you can see the green LED blinked and access is granted. That message is shown here in the fingerprint sensor here. So access granted. So matching is successful. And if I place a finger that is not present in the fingerprint sensor, you can see the access is failed. So the red LED is blinking. So the whole system is working right now, and if we need to add another fingerprint, we can just add it here on the system. And we have two fingers here. So we have two fingers added. You can log in with one finger and log out with another finger. Yes. So to see the data here, we have to go to the employees and see the attendance thing here. So you can see here the fingerprint was checked in successfully. That last time we added 2 times, so it has marked as total hours as 0.01. So this one is still working because we only checked in at 1:28 a.m. and we are still waiting for some time to show that this fingerprint will be added later. After 1 hour or something, the hours will be automatically calculated. I will just add one more time. So it's authenticated. You can see the green light. If I refresh this page, you can see the fingerprint calculated the total hours and checked it. I checked out of the system. So this is how the whole thing works. In future, we can add much more fingerprint sensors to a single network using a VDL thing and coding a FPGA array and adding it to the network, sending the API directly to the server and everything. And this is the working model of attendance and access control using fingerprint sensor, Raspberry Pi, cloud and actuators. Thank you.